Hello, so we're doing one of our reviews here today, looking at the patterns with fractions. Okay, so this first step is find the difference and write it in its simplest form. Okay, so the first thing again we need to do is get common denominators on these fractions, okay, that we're subtracting. So I'm going to multiply this left side by 2 over 2. So 2 times 1 is 2. 2 times 5 is 10. The big number of 1. Now over here, 5 times 1 is 5. 5 times 2 is 10. Now we have common denominators. That's good. But 2 minus 5 would give us a negative number. So we have to borrow from one of these hot unopened pizzas over here. So that is going to turn into 0 whole unopened pizza, 1 brand new pizza with 10 of its slices, and then the cold slices here that we had originally. So 10 and 2 makes 12 over 10 minus 5 over 10. Okay, common denominator, 12 minus 5 is 7 over 10. Okay, so that was a review of subtracting fractions. And now we're going to look at some of the patterns, how we solve these patterns. Okay, so we first need to make sure that they are like fractions, and we look at the denominator to make sure that is happening. So we're looking for writing a rule for the sequence to see what the next one might be. Okay, so 1 3/4, we want a denominator of 8 here. So how do I go from 4 to 8 using multiplication? I would, of course, double it. So 4 times 2 would be 8. 3 times 2 would be 6. Okay, now let's just copy down the rest of the problem here. So we had 1 3/8. The middle term is now, instead of 1 3/4, 1 6/8. Then we have 2 1/8. So what is the pattern here? So how many steps did we go here on the whole numbers? None, right? From 1 to 1 we didn't go up at all, but we did go 3/8 to 6/8, so that between here and here is a change of plus 3/8. Then what happens? If we were to try to do that jump again, we would have 7/8, 8/8, and one more. We'd have 9/8. So then what ended up happening, that's why this whole number clicked over from 1 to 2, is because if we do 6/8 plus 3, again, that would give us 9/8. And remember how we would split this from a fraction where the numerator is larger than the denominator? We would be adding one whole number, because this would be the same as writing 8/8 and, okay, one more 8th to make our 9/8. Okay, so that's why, this is the reason here why it clicked over from 1 to 2 on the whole number before. And that's why the clock started over from the top again when counting our fractions. So we had 3/8, 3, 4, 5, 6/8, 7, 8, 9/8, which changes into adding 1 to the whole number and 1/8. But the change that happens each time is 3/8. Okay, let's try another one. So let's look at the pattern. Now all of these are in like fractions, as a matching denominator. How would we figure out the pattern though? What are we gaining or losing? So between the whole numbers here, 1 to 1, there's no change on the whole numbers. But what about the fractions? So going from 9 to 7, that would be minus 2. Let's see if the pattern holds up. If we went here and we did minus 2 again, and here minus 2 again, does it make sense if we did 7 minus 2 would be 5, minus 2 again, once more would give 3, right? 9, 8, 7, 6, 5, 4, 3. You see the pattern that each step are losing 2, and of course the denominator is 10. So we're losing 2/10 each step. Okay, so we're losing 2/10 each step. That's how much we're losing each step of the way. Okay, try one more. So here the whole number does not change. The fraction does, and then here the whole number changes and the fraction does as well. Let's get this into matching fractions first of all. So this is going to stay 2 and 5/12. How would I go from 6 to 12 using multiplication? I'd of course double it, so 6 times 2 is 12. The numerator, 1 times 2 would be 2. Okay, and this is already in 12ths, so that's good. So what would this step coming up be? So from 5 to 2, how much are we losing or gaining? Okay, the whole number didn't change, but from 5 to 2, that's 3 steps down, right? 5, 4, 3, 2. Okay, now does it make sense if we were dealing with 12ths? And you can think of fractions as a little bit of a clock. Each time it turns over, it makes or loses a whole number. So if we start at 5 and we go down 2, so down 2, so 5, 4, 3, 2, 3 steps. What if we took 3 more steps away? We would go 2, 1, 0, and then or 12. So we go from 2/12 to 1/12 to 12/12 to 11/12. So it's 3 steps. So we end up losing one of the whole numbers and starting over at the top. Okay, so the steps that happen here again would be 2 and 1/12. We would lose one more and we'd go to 2 and 0/12. So these are like the intermediate steps that are happening in here. Then we would lose one more. There's no more fractions to take away, so it would be 1 and 11/12. Okay, we see how that pattern emerged, and that would be how we would get to the 1 and 11/12. Okay, so we're losing 3/12 each step, just like that.